Welcome to this video on electronic structure and isotopes, your complete GCSE Chemistry revision guide to atomic structure, electron shells, isotopes, and ion formation. This guide covers the structure of the atom, electron shells, electronic configurations, isotopes, and relative atomic mass, ions, and ends with exam tips and practice. Chapter 1 is all about the structure of the atom. Atoms have a nucleus surrounded by electrons and shells. Protons in the nucleus have a +1 charge and define the element. Neutrons are neutral. Electrons orbit in shells with a -1 charge. In a neutral atom, electrons equal protons. This table summarizes the key properties of subatomic particles: location, relative mass, and relative charge. Remember that a neutral atom has equal numbers of protons and electrons. The atomic number Z is the number of protons, which identifies the element and equals the number of electrons in a neutral atom. The mass number A is the total number of protons and neutrons. Neutrons can be found by subtracting the atomic number from the mass number. For sodium Na, the atomic number of 11 means 11 protons and 11 electrons. The mass number of 23 means 12 neutrons, 23 minus 11. Chapter 2 focuses on electron shells and energy levels. Electrons fill shells closest to the nucleus first. The first shell holds a maximum of 2 electrons. The second and third shells each hold a maximum of 8 electrons at the GCSE level. 3 rules for placing electrons: fill from the inside out, respect the maximum capacity of each shell, 2 in shell 1, 8 in shells 2 and 3, and count carefully to match the atomic number. Chapter 3 covers electronic configurations. Electronic configurations show the number of electrons in each shell, separated by commas. This table shows the configurations for the first 20 elements. To build the configuration for carbon Z equals 6, it's 2, 4. For chlorine, Z equals 17, it's 2, 8, 7. For sodium, Z equals 11, it's 2, 8, 1. To draw electron shells, start with the nucleus. Then, draw shell 1 with up to 2 electrons. Follow with shell 2 up to 8 electrons, and finally shell 3 with the remaining electrons. Always ensure your electron numbers are correct. The periodic table links to electronic configurations. The group number reveals the number of outer electrons. The period number indicates the number of electron shells. The number of outer electrons determines an element's reactivity. Elements with 1 outer electron, like group 1 metals, are very reactive, easily losing that electron. Elements with 7 outer electrons, like group 7 nonmetals, are also highly reactive, needing 1 electron to complete their shell. Noble gases with 8 outer electrons are stable and unreactive. We move now to Chapter 4, Isotopes and Relative Atomic Mass. Isotopes are atoms of the same element with the same number of protons, but different numbers of neutrons. This means they have the same chemical properties, but different mass numbers. Carbon has 3 isotopes: carbon-12, carbon-13, and CaR-BON-14. Notice that the proton number 6 is constant, maintaining its identity as carbon. The varying neutron count, 6, 7, and 8, leads to different mass numbers, 12, 13, and 14. Chlorine exists as a mixture of chlorine-35, with 18 neutrons, making up about 75% of natural chlorine, and chlorine-37, with 20 neutrons, making up about 25%. This mix is why its relative atomic mass is not a whole number. Isotopes occur naturally because atomic nuclei can form with varying numbers of neutrons. Some are stable, like carbon-12, while others are unstable and radioactive, like carbon-14. Relative atomic mass, or AR, is the weighted mean mass of an atom compared to 1/12 the mass of a carbon-12 atom. It accounts for the mass and natural abundance of each isotope. Remember to divide the final calculation by 100 when using percentage abundances. To calculate the relative atomic mass for chlorine, multiply the mass number by the percentage abundance for each isotope, 35 by 75 plus 37 by 25. Add these products, 2,625 plus 925 equals 3,550, and then divide by 100 to get 35.5. This non-whole number is the weighted average. Chapter 5 is about ions, atoms gaining and losing electrons. An ion is an electrically charged particle formed when an atom gains or loses electrons. Positive ions, or cations, form when electrons are lost. Negative ions, or anions, form when electrons are gained. Remember, Leo the Lion says GER. Loss of electrons is oxidation, gain of electrons is reduction. Metals form positive ions by losing outer electrons. Sodium loses 1 electron to form Na. Magnesium loses 2 to form Mg squared. Aluminium loses 3 to form Al cubed. The number of electrons lost equals the ion's charge. Non-metals form negative ions by gaining electrons to achieve a full outer shell. Chlorine gains 1 electron to form Cl. Oxygen gains 2 to form O squared. Nitrogen gains 3 to form N cubed. The number of electrons gained equals the negative charge. When forming an ion, the proton count remains constant, ensuring the element remains the same. Only the number of electrons changes, leading to a net charge. Ion electronic configurations reflect the new electron arrangement after losing or gaining electrons. For example, Na is 2, 8, and Cl is 2, 8, 8. Most ions achieve the stable, full outer shell of a noble gas. We finished this video with Chapter 6, reviewing atoms versus ions versus isotopes. Confusing atoms, ions, and isotopes is a common mistake. This comparison helps you keep them straight. Atoms are neutral, ions are charged particles, and isotopes have different numbers of neutrons. Atoms, ions, and isotopes all have a fixed number of protons based on the element. The differences lie in the number of neutrons and electrons, which affects charge and mass number. Atoms are neutral, ions are charged, and isotopes have varying mass numbers. Let's apply this to chlorine. Species A is a neutral chlorine atom. Species B is a chlorine isotope with 2 extra neutrons but is still neutral. Species C is a chloride ion with 1 extra electron, giving it a negative charge. Now we move to Chapter 7, focusing on key definitions you must learn for your exams. Key definitions include atomic number, the number of protons; mass number, the total protons and neutrons; isotopes, atoms of the same element with different neutrons; relative atomic mass, the weighted mean mass compared to carbon-12; and ion, a charged particle from gaining or losing electrons. More definitions to memorize. Electronic configuration is the arrangement of electrons in shells, like 2, 8, 1. An electron shell is the region where electrons orbit. A cation is a positive ion formed by losing electrons. An anion is a negative ion formed by gaining electrons. Finally, we reach Chapter 8, Exam Tips and Common Mistakes. Follow these guidelines to maximize your scores. Our top exam tips include: always show you're working for relative atomic mass calculations. State both protons and electrons when describing atoms or ions. Use the correct isotope notation, and always include units and charges. Avoid these common mistakes: confusing mass number with atomic number, claiming isotopes have different proton numbers, overfilling electron shells, and forgetting that ions still have the same proton count as the original atom. Time for practice questions. Q1 asks for the subatomic particles in a neutral phosphorus atom. Q2 asks for the electronic configuration of sulfur. Q3 asks for the relative atomic mass of copper based on isotope abundance. Try them and check your answers. Here are more practice questions. Q4 asks for the difference between an atom and an ion using sodium. Q5 asks for the definition of isotopes with an example. Q6 asks for the number of electrons in an oxide ion. Use this quick-fire quiz to test your memory of the essential definitions. Focus on giving precise, word-for-word answers for each term. Remember these key stats. The first electron shell holds a maximum of 2 electrons. Shells 2 and 3 hold 8 electrons. No configurations for elements up to atomic number 20. And remember, chlorine's relative atomic mass is 35.5. This topic summary is your final checklist. Ensure you understand all points, from subatomic particle properties to calculating relative atomic mass and explaining ion formation. You have covered all the key concepts for electronic structure and isotopes. Remember to revise the definitions, practice the calculations, and check off every point on the summary. Good luck with your exams.